Hi friends, this is Gopal, Head of the Department of Humanities and Science. In this video, we have to discuss how to find Laplace transform of the given function. That function is divided by t. So generally we have one of the statement. If Laplace transform of f of t equal to f bar of s, then Laplace transform of f of t by t means the given f of t is divided by t. This is equal to integral s to infinity f bar of s ds. So means if any function is given, means for example find the Laplace transform of sine t by t is there. So what is f of t here? This is f of t. Means first we have to find out Laplace transform of sine t, and that is denoted by f bar of s, and we have to substitute here. Then integrating f bar of s, so finally we get the required Laplace transform of the given function. So mainly in this video we have to discuss how to find the Laplace transform of f of t, that function is divided by t. Okay, we will see one example. Find the Laplace transform of sine t by t. Yes, we know that one of the formulas, so that is if Laplace transform of f of t equal to f bar of s, then Laplace transform of f of t by t equal to integral s to infinity f bar of s ds. So in order to find this integral, first we have to find out f bar of s. So what is f of t here? F of t equal to, in the given function, f of t equal to sine t. So therefore first we have to find out Laplace transform of f of t. This is equal to Laplace transform of sine t. We know that Laplace transform of sine t, so this is equal to 1 by s square plus a square. So where a equal to 1, so that's why we are getting 1 by s square plus 1, and this is said to be f bar of s. Now we have to find out Laplace transform of f of t by t. So means Laplace transform of sine t by t. So this is equal to integral s to infinity, and f bar of s. What is f bar of s here? 1 by s square plus 1 square. S square plus 1 square, and we have to substitute here. So our convenience, 1 by s square plus 1 square can be written as this form. Okay, now we have to find out integral of 1 by 1 plus s square ds. We know that one of the formula integral 1 by a square plus x square dx equal to tan inverse of x by a. Okay, so therefore by using this formula, so this integral becomes to this form here. So why? Because this is 1 by a square plus s square form, and this is equal to tan inverse of s by 1. Now these are the limits, s to infinity. Then we have to substitute upper limit and lower limit. Limit t tends to infinity, tan inverse of s, or directly we written this is tan inverse of infinity. So minus tan inverse of s. Why? Because here s is the lower limit. So tan inverse of infinity equal to pi by 2, and this is as it is, minus tan inverse of s. So therefore pi by 2 minus tan inverse of s can be written as cot inverse of s. So therefore Laplace transform of sine t by t equal to cot inverse of s. This is the process of finding Laplace transform of the given functions. That function is divided by t. Now we shall discuss one more example. Find the Laplace transform of 1 minus t by t. Here first observe the given problem. The given problem is like that. Find the Laplace transform of f of t by t, means the given function f of t is divided by t. So we have the one of the statement, if Laplace transform of f of t equal to f bar of s, then Laplace transform of f of t by t equal to integral s to infinity f bar of s ds. So first we have to find out f bar of s. So Laplace transform of f of t equal to Laplace transform of 1 minus e power t. Why? Because the given function f of t is 1 minus e power t. Laplace transform of 1 minus Laplace transform of e power t. So we know that now since Laplace transform 1 equal to 1 by s, Laplace transform of e power at equal to 1 by s minus e. These are the standard forms. By using these standard formulas, Laplace transform of 1 can be written as 1 by s, Laplace transform of e power t equal to 1 by s minus 1. This is f bar of s. Now we have to find out Laplace transform of f of t by t means Laplace transform of 1 minus e power t by t. In right hand side, this f bar of s is replaced by 1 by s minus 1 by s minus 1. Now we integrating this f bar of s. So first we integrating 1 by s with respect to s. So therefore now integral 1 by s or 1 by x dx equal to this is log x. This is the direct formula. So therefore integral 1 by s ds equal to log s, and coming to this function integral 1 by this in the form of 1 by x minus 1 dx. So means this in the form of integral f bar of x by f of x dx. This is equal to log x, log f of x, log f of x. So by using this integral, so this is in the form of integral f bar of s by f of s ds. So therefore this is equal to log of s minus 1. So before going to substitute limits, and we have to return this is log s. So here log a minus log b equal to log a by b. By this property, log s minus log s minus 1 can be written as this form. Why? Because this is log a minus log b. So therefore log a by b. In denominator we are taking s common. So our convenience we are taking s common. So therefore we are getting here s, this is cancelled. Okay, now we have to substitute the limits. First we have to substitute upper limit. Log, here 1 is there, 1 by, this is cancelled. So that's why we are getting only 1 by 1 minus 1 by s. Yes, this is upper limit minus lower limit. Lower limit is s log 1 by 1 minus 1 by s. Why? Because this limit is as it is, same s. Here this value, only this value is becomes to 0, 1 by infinity value 0. So therefore 1 by 1, we are getting log 1 minus, so in denominator this is 1 by 1 minus 1 by s equal to, in denominator s is LCM, s minus 1, 1. So therefore this is s by s minus 1. Yes, we written here s by s minus 1. Log 1 value 0 and minus log s by s minus is there, and this can be written as, so in case log minus log a by b is there, this is exactly equal to b by a. By using this log property, minus log s by s minus 1 can be written as log s minus 1 by s. This is the process of finding Laplace transform of 1 minus e power t by t. So first observe these things. So this is very important step here. First we return, first we find out integral of these functions 1 by s, 1 by s minus 1. So before going to substitute upper limit and lower limit, here we are taking s common. Okay, in denominator we are taking s common. This is a key point. And remember this thing. So then we have to substitute upper limit and lower limit. Yes, we have to see one more example. Find the Laplace transform of e power minus at minus e power minus bt by t. So what is f of t here? This numerator is f of t. This f of t is divided by t. So first, if any problem is given, first identify. So the given f of t is divided by t or not. Yes, the given function f of t is divided by t. So therefore what is the statement here? If Laplace transform of f of t equal to f bar of s, then Laplace transform of f of t by t equal to integral s to infinity f bar of s ds. Yes, what is f of t? F of t e power minus at minus e power minus bt. Now we have to find out Laplace transform of f of t. Yes, now this is Laplace transform of the given function, and we written Laplace transform into each and every exponential function. So therefore Laplace transform of e power minus at minus Laplace transform of e power minus bt. Yes, we know that Laplace transform of e power at, Laplace transform of e power at equal to 1 by s minus a. So here this is minus a, so that's why 1 by s plus a minus, this is Laplace transform of e power minus bt. So therefore this is equal to 1 by s plus b. This is called f bar of s. In order to find Laplace transform of f of t by t, so right hand side this f bar of s is replaced by 1 by s plus a minus 1 by s plus b. Yes, we have to written here. Then this function f bar of s can be written as this form: integral s to infinity 1 by s plus a ds minus integral s to infinity 1 by s plus b ds. So now we find out integration of this function. So this is in the form of integral f bar of s by f of s ds. This is equal to log s. So this integral is in the form of integral f bar of s by f of s ds. This is equal to log s. So that's why here we written log s plus a, and we written the limits s to infinity. And similarly this is also in this form: integral f bar of s by f of s ds. This is equal to log s plus b, and these are the limits. Now we have to substitute upper limit and lower limit of first function and second function. Yes, what is the upper limit here? Infinity. Log of infinity plus a equal to log infinity, and this is lower limit is s, so that's why we are getting the same function log s plus a. And coming to the second function, upper limit is infinity, log of s infinity plus b. This is equal to log infinity minus log of s plus b. Here log infinity equal to 0, and minus log s plus a is as it is, and minus of this function log infinity, again this is 0, and minus plus log s plus b. So therefore log s plus b minus log s plus a. So by using this log property, log a minus log b equal to log of a by b. So therefore this expression can be written as this form: log s plus b by log by s plus a. So this is the Laplace transform of the given function. Here the given function is divided by t. We will see one more example. Find the Laplace transform of 1 minus cos t by t. So what is f of t here? 1 minus cos t. So this f of t is divided by t. This is the statement: find the Laplace transform of, if Laplace transform of f of t equal to f bar of s, then Laplace transform of f of t by t equal to integral s to infinity f bar of s ds. First we have to find out Laplace transform of f of t. Laplace transform of 1 minus cos t. So therefore we have to written this is into this form: Laplace transform of 1 equal to 1 by s, Laplace transform of cos t equal to s by s square plus 1 square. Why? Because here a equal to 1, so that's why we written s by s square plus 1 square. This is called f bar of s. So therefore we have to find out Laplace transform of f of t by t. Laplace transform of 1 minus cos t by t. This is equal to integral f bar of s ds. In right hand side, f bar of s is replaced by s 1 by s minus s by s square plus 1. So that's why here we written this is as a f bar of s. Now we have to find out integral s to infinity 1 by s ds minus, so here this is s by s square plus 1. So our convenience here, this numerator and denominator multiplying and divided by 2. 1 by 2 integral s2 infinity 2s by s square plus 1. So why? Because we have one of the formula, integral f bar of s by f of s into ds equal to log f of s. In order to apply this integral, this form of integral into this function, this is f of s. What is f of s here? F of s equal to s square plus 1. F bar of s means we have to differentiating this s square plus 1, therefore this is 2s. So this is 2s, but we have only one s, so that's why this numerator and denominator multiplying and divided by 2. So now we apply this formula directly here, integral f bar of s by f of s ds, this is equal to log f of s. What is f of s here? S square plus 1. And first function, integral 1 by s ds equal to log s. Now we have to substitute upper limit and lower limit. So therefore log infinity minus log s. So these are the limits of the first function. And coming to the second function, minus 1 by 2 log infinity square plus 1 means infinity minus, this is the lower limit, log s square plus 1. So first these values are zeros, this is 0, this is 0. So therefore we getting directly directly minus log s. So this is 0, minus into minus plus 1 by 2 log s square plus 1, right? So again we use this property, log a minus log b equal to log a by b. So here this is minus log s plus 1 by 2 log s square plus 1 means, so we return this is s square plus 1 whole square. So a or some p log q equal to log q whole power p. So this is also property, log property. So that's why this 1 by 2 can be written as the power of s square plus 1, and minus log s is there, so that's why it can be written as a by b. Okay, so this is Laplace transform of 1 minus cos t by t equal to log s square plus 1 whole power 1 by 2 by s. So this is the process of finding Laplace transform of the given functions, and the function is divided by t terms.